Hi, welcome to my channel. This is Elements of Learning, where we talk about chemistry and just kind of go through what things are, why they matter, and what makes it cool. I'm Cam Kiernan, and something about me is that I just love chemistry. I went to school for chemistry, I used to teach chemistry, and honestly, I just kind of miss chemistry. So what we're doing is we are going to go through this book, just sort of talk about the things of chemistry. Like I said, we're going through this book, and if you don't have that book, that's okay, because chemistry hasn't really changed. General chemistry is basically the same in every book. So whether you have this book or a different book, we're just going to go through it from the beginning, start with the basics, and sort of see where that takes us. We got to talk about matter. Matter is the building blocks of basically everything in chemistry. I think matter and energy are really, to me, the most important parts of chemistry. So it's really important that we start with matter. So matter, as defined in this book, matter is anything that has mass and occupies space. So that's anything that has mass and has volume. And matter is classified in a few different ways. We can classify it based on its phase. So that is our solid, liquid, and gas. Those are our three main phases. And I say main phases because there are some secret phases that we don't really talk about in general chemistry. And if you know what they are, put it in the comment and you get a gold star. But we're just talking about solids, liquids, and gases today. So they're mainly defined based on how their particles are interacting with their space. So a solid has a fixed shape and a fixed volume. No matter what container you put it in, it's always going to look exactly the same. You can take a rock and put it in a beaker. It's still going to be the shape of the rock. It's not going to take on any new shapes. Unlike liquids. Liquids have a fixed volume, so they're always going to be the same amount, but they take the shape of their container, which I think is like pretty dope. Its structure is that the particles can kind of slide a little bit, and that's how it's able to take the shape of whatever container it's in, which I think is like really the cool part about liquids, and it's my favorite part about gases. Gases have no fixed shape and no fixed volume. So they take not only the shape of their container, but also the volume of their container. If you release a little bit of gas into a room, it's going to take the shape of the entire room, and it's going to fill up the entire room. That's because its particles are moving very fast, and so they're able to like move past each other really well. That's why if you've ever farted in a room, that smell can go the whole room. I'm not speaking from experience. I'm just saying. I'm just letting you know. That's how we classify matter based on its phases. However, we can also classify it based on its composition. So its composition, that's going to be whether it's a pure substance or a mixture. A pure substance is like an element or a compound. An element or a compound, it's kind of just one thing. Versus a mixture, which is a physical combination of two or more substances. We'll probably talk more about elements and compounds, but if it's something you're interested in, definitely leave it in the comments, let me know, and I will make a video immediately. So quick, you won't even know. Quicker than a gas's particles. Maybe. But mixtures, that's where it gets interesting. Mixtures have typically two types. We have homogeneous or homogeneous and heterogeneous or heterogeneous. Just depends on how you want to say it. I like homogeneous, heterogeneous, I think. We'll see what I end up saying throughout the video. Like I said, a mixture is a physical combination of different substances. And those substances, because it's only physically combined and not chemically combined, it has not gone through a chemical reaction, those substances are going to retain their original properties. Let's start with a heterogeneous mixture. A heterogeneous mixture, that's when you mix things together, but you can still kind of see the differences in there. My favorite example of this is when we have a salad. When you make a salad, you can typically see all of the different pieces in that salad. You can see the ingredients, and since you can see the different parts of it, you can tell that it's a heterogeneous mixture. So another example would be like sand, where you can see each individual piece. Another example would be granite, where you can see the dark parts and the light parts, and you can kind of see the different parts that make up the whole. And the other type of mixture is a homogeneous mixture or homogeneous mixture. A homogeneous mixture is when things are mixed together and you can't see the different parts in there. It all just looks like one thing. So one example of a solid homogeneous mixture would be a metal alloy. So for example, brass. Brass is a mixture of copper and zinc, and when you look at it, it just looks like one thing. You can't pick out the copper, you can't pick out the zinc just by looking at it. Another word we use for our homogeneous mixtures is a solution. So solution is when you have a solvent and a solute. Typically the solvent is a liquid and we're dissolving something in it. So an example of a solution would be like salt water. You take salt, you dump it in some water, you mix it all together, and as it dissolves, it becomes just one thing. You can't pick out the salt and pick out the water just by looking at it. It all looks like just one thing. Now, because a mixture is physically combined, it can be physically separated. Like I said, sometimes it's hard to do, but it's not impossible if it's physically combined. One thing we could do, for example, if we have a bucket of sand, we could pick out the different types of sand. It'll take a million years, but you could do it if you tried. My favorite example to talk about separation is pasta and water. Let's say you made some pasta. Now you have pasta and water in the pot. You're hungry. You want to get the water out of there. You want to start eating that pasta. You want to put some sauce on, maybe a meatball, maybe two. I don't know. I don't know how you do it, but you want to get that water out of there. You want to separate the water from the solid pasta. Now, there are a couple ways to do this. You could use filtration, and filtration is like, for example, using a colander and pouring the water through the colander, pouring your mixture into the colander. The solid pasta stays in the colander and the water flows through it, and you're left with just solid pasta in the colander. You've filtered out the water. Another way to do it is you can decant it. Decanting means you are slowly and carefully pouring off the water while leaving the solids in the container. So that's when you don't have a colander, you're just kind of slowly pouring the water out. That's what I do because I hate getting a colander dirty. And the last one we'll talk about is distillation. Distillation in this example is if you leave the water, the pasta water if you leave the pasta and water on the stove and just wait for all of the water to evaporate, might take a while, might burn your pasta. But all of the water will evaporate out and you'll be left with just the solid pasta in there. Not ideal, but you get the point. So those are some ways to separate out a mixture. Today we talked about what is matter, the different phases, solids, liquids, and gases, and the different types of compositions it might have. Pure substances, elements and compounds, and mixtures, homogeneous and heterogeneous mixtures. And we talked a little bit about how to separate out those mixtures. So we talked about filtration, distillation, and decantation. If you want to talk more about elements and compounds and what exactly those are and how to classify them and what's the difference between a compound and a molecule, just let me know in the comments and we can talk about it. Like I said, I'm very new to YouTube. Please like, subscribe, send it to someone that might need some help. I am so stoked to be talking chemistry again and cannot wait for the next episode. You know, we're working through the book. Anyway, thank you so much for watching my channel and hopefully I'll see you soon. Bye.